a CryptoHacks challenge, and the challenge we're gonna be doing today is gonna be called vectors. So, but this challenge says before defining a latency or talking about how latencies appear in cryptography, let's review some of the basic of linear algebra. The following challenges should be considered original. If this is totally new to you, you might need to do a bit of background reading as usual. We recommend Introduction to Mathematical Cryptography by Hofstad, Pfeiffer, Silverman, and as well as Introduction to Latencies and Their Applications. A vector space over a field F is said to define with two binary operators for every vector in V and scalar A to F. Vector addition takes two vectors and produces another vector. So V plus W is VWZ. And scalar multiplication takes a vector and a scalar and produces a vector. A times V equals W for VWAF. Let's consider a two-dimensional vector space over the reals. A vector can be considered a pair of numbers of V and AB, and AB is part of the vector. Vectors addition works as V plus W, and you just multiply the two values AB, or add the two values AB and CD as AC plus BD. And scalar multiplications times C, V, and then V is A and B, and then you multiply the scalar to every part to the point. One calls to define inner product, also called dot product, which takes two vectors and returns a scalar. Formally, as we can think as V and W. So in B and W, you just multiply A and C plus B and D, and I guess you just add them all up. Time for the flag. Given the three-dimensional vector space defined over the reals where V equals 263, W equals 100, and U equals 772, calculate this following equation. So let's use Python interpreter. Python 3 interpreter. Let's get the ball rolling. So let's see, we have these values. Hopefully we get something out of this. V is that, so we'll call it V is equal to colon, and then we'll have W is equal to that, but as a colon, so it's going to be considered a list, and then that's going to be the last list right there. So we got two lists, VWE, and then we had to follow this equation, 3 times 2U and all that. So 2U. All right then. So first let's figure out this part. So let's do 2 times U. So that's gonna be for every X. So we'll call this new U equals empty list. And now for every X in U, then we're gonna do new U is gonna we're gonna append a value, multiply times X, and then print out new U. And then I'm just gonna put this as a type of, I guess, comment, just to get an idea. 14, 14, 4. So that does this part. Now we need to do this inner part. Okay, so TV. Okay. So we're gonna call this new V. New V is gonna be something that's empty, and then for every X in V, we're gonna do the exact same thing. New V times append X times 2. And then we're gonna print out new underscore V. 4, 12, 6. 4, 12, 6. Okay, and now we're gonna subtract it by W. So can you just do this? Print new V minus W. Will that work? Yeah, that didn't work. You can't. So you're gonna have to do it like for every X in a range of 3, because there's 3 values, and then we're gonna do print new V at that specific value minus new minus w, and then x, and now x. If you run this, I guess I forgot this, right? 3, 12, and 6, because that's 4, 12, and 6 minus that. 3, 12, and 6, that only subtracts that one. So we're right here. So now we got this part and this part done. So do we do the scalar multiplication first, or we do that at the end? Let's assume we do that at the end, and let's just multiply these two vectors next. So let's do something like print. We need to make a new, I guess, w, since we haven't had one like that. New w equals that, and then we'll do new w dot append, and we're just gonna append every one of these values to it, and then we're gonna do print just to make sure that has the correct values. Print new w. 3, 12, and 6 should be it. And now what we're gonna do is let's do this. For every x in, we have to multiply to new u. So for every x, for every y in range of 3, we'll do for every y in range of 3, we'll have to multiply then add them all together. So I'll just do print multiply and add them all together. So we'll just do answer is equal to 0, and we'll do answer plus equals new w at y times new u at y, and then we're gonna print out the answer 234. So we got all of this done right now, and obviously just multiply times 3. So times 3, 702. That's our final answer. So now if we go back and check the solution, we get 702. So basically what we did is just first focus on this part of the equation, and then lastly focus on this part, and at the end we just do the last scalar multiplication at the end, and just focus on this and then multiply it times 3 at the end. So this is us breaking it down to the final solution using code. So 702 is the final answer, and as you can see here, the flag was 702. So yeah, that's about it. Hope you guys learned something new today. I know I did, and I'll see you guys in the next one. Peace.